Howdy.
Howdy.
Happy Halloween, as they say. Not that I understand that because I'm foreign. But the thought of people coming to my door asking for candy is still a weird thing. Anyway, they can't because I'm here.
You got some right there.
So we're going to talk about an artificial intelligence system called stat626 Studio. Which automatically fits models, time series models. Okay. We're going to do this over 2 weeks. This week we're going to, when the world works well, and try and understand, all the features of the vehicle. Now, a lot of things are sort of still secret. They don't tell you exactly how they do it. There's a big manual that I put up on the website that has hundreds of pages, which being recorded. But anyway, it's very difficult to pin down exactly how they do stuff. But we'll see that we get the general idea. And some of it drives me crazy the way they do things, as you'll see. So I get very excited. I get very excited when it comes up in a negative way when it beats my models.
Oh.
And it does sometimes.
Does it? Oh, man.
So, automatically fitting time series. So I like to do it when I get really stuck. I'm a purist. I try and fit my own models first, so I know what I'm looking for. But when I get really stuck, I will go and have a look at this. I don't generally just put something in and say, tell me what you get. I've already looked at the data. So, what it's designed for is, it has this by command. So imagine you work for a company that had regions. Or you work for a company and you manage a whole series of stores. So it will fit different models for the different regions of the different stores, automatically. Which sounds really attractive, doesn't it? Manage 50 stores, let's have 50 models. It's a lot of work to do those. Now, I know the people that put this together and their algorithms are really sound. And they say this is for folks who are not time series experts. You guys are becoming time series experts. If you think about how much we've learned in just part of the semester, it's quite interesting, isn't it? So, the stuff in blue automatically selects the appropriate model based on a user-defined criterion. Holdout samples can be specified. You can do, it'll find and detect outliers and fit what it thinks is the best model at the same time, which is better than what we've been able to do, right? In theory, better. So, I just got mine updated. I've got 14.2. I believe you have 14.1. I don't think there's a major difference. I'll ask Ms. Kim about how we get yours updated, if we see anything different. But I didn't notice anything different when I redid all of the class notes from scratch from last year. Some of the models are a bit different. So at the same time, detect and allow for outliers and level shifts, and determine which models optimize the chosen fit criteria. So let's start with something where I know the answer. So I've generated 1,000 points from a remonth PDQ. So when we look at the data, the first thing is that you need a date variable. You need a time variable in stat626 Studio, because it wants to figure out what the seasonality is. If it's daily data, it's going to think of day of the week. If it's monthly data, it's going to think of month of the year. If it's quarterly data, so you have to have a date. So you'll see I've made up 1,000 points and said that it went till the end of September this year. We look at the PACF, and what do we see? Well, we look at the graph, and we see that the mean is changing a lot over time, isn't it? We look at the ACF and it doesn't die out over a long period, so we can't control ourselves, we want to. Difference. Remember all the grief you gave me in the first couple of weeks? Now you're just as mad as me. You want a difference, right? You see that, you can't control yourself. Now once we do a difference, what do we see? The differences look stationary, don't they? When we look at the ACF and the PACF, nothing really pops out of our porridge, does it? So it looks like we've got an armour process going on here, and in that case, as we know, SUDS, ACF and PACF tells us nothing about the order, does it? So we're going to be conservative and we're going to go up to 5. I'm going to look for P equals 5, Q equals 5, because 5 is the last one that kind of pops close to the blue line. It's being very conservative, right? We push go, and it comes up with an ARIMA 111. Well done. That's how I generated the data. Right? I generated the data from a model with P equals 1, D equals 1, Q equals 1. So we got back to truth. It's not hard because there's 1,000 points. Are we good? Then we fit. I think, well, I know that the AR1 coefficient in the estimated, the model coefficient is 0.6. The MA1 coefficient is minus 0.6. And the mean was like 0.3 or 0.35. So we got those back pretty well, didn't it?
Yep.
And if we look at the residuals, it looks like white noise. Now the really interesting thing is, if you look, some outliers appear, don't they? Like that looks like a bit of an outline, doesn't it? And they're really not. It was generated from normal data. Stuff happens sometimes. Right? 3 in 1,000 points are outside 3 standard deviations. Normal data. So we're good. That's how we do things. So let's start a really simple test. We're going to put that in this intelligence, in this artificial intelligence system, and see how it does, right? Yes? Doesn't that sound good?
That sounds great.
Sounds really fun.
Nah,
So, let's go to SAS Forecast Studio. I have every step, and I want us to do this together. So if you open it, you get this box. How we do it? Distance, guys? How are we doing? Aaron? Adam? Adrian? Diego? Are you there yet?
Starting out.
It's a little slow to open.
It's not opening for me.
It's slow. It's good time.
It's slow.
It takes a long time to open.
It's slow.
Yep, it's here.
If it's the first time, it's
Yeah, don't click it twice.
Okay. So this is where I tell my jokes, right?
Yeah.
sure.
All right. So no joke, Dr. Cheese? This is where you tell your jokes.
Yeah, this is where I tell my jokes, but I think you've heard all of mine about 5 times.
We'll still laugh.
Well, in the future, whenever you got field time, you can always talk about you and Dr. Jones' road trips.
Our road trips, we're actually going on one on Sunday. We're going to the Southeastern SAS User Group Conference at the SAS offices in Cary, North Carolina. So yes, Jones and I were going on a road trip. Imagine that.
Yes.
Is he driving you there?
No, of course it's not driving. We're catching aeroplane.
You going on the bike?
Sorry?
You going on the bikes?
No, we're not going on motorcycles. We're just going to catch an aeroplane.
Dr. Steven, I got mine open.
You got it open. Thank you for letting me know.
Mine has an error message. It says an error occurred. The list of projects could not be retrieved. Save the details of this message and contact your system administrator.
Okay, so I would get out of that and try and restart again.
IT 101.
I just said okay, and it looks like it's still working.
Okay, good,
Maybe it's fine.
good. Anybody still got a problem?
Dr. Sheehan, this is Laura. Just so you know, I have 14.2 on my computer for some reason, so
You probably followed the instructions from Miss Kim and updated.
Okay, just wanted to let
So you're a good little Vegemite, as we say in Australia.
What?
Where are these so-called instructions?
So it doesn't matter which one you have, just make sure you have it open. Are we good?
Good?
Okay, it's opening. So we're going to open, then we're going to click on new, because this is a new project. It's our very first one. So I use one of the student computers, not mine, because I've got lots of projects, so to make it look exactly like yours. Click on new. Then you type in a name. I called it Arima PDQ. Are we good? We click on next. Now, double click on SAS user. And then you should find, that's where you've got to put the file. You've got to put the data file, Arima PDQ. So up on the website, on eCampus, there are 3 files for today. Arima PDQ, the main MAINE one, and New York City Taxi fare box. Now we might need some help, boss, with where do they put those files?
So if you go to Documents, you open up the folder directory, go to Documents, there'll be should be a SAS.
It says My SAS Files,
My SAS files, 9.4.
and you put them in there.
Yes. And then you should be able to access
Come again, what was that?
So if you go to My Documents, My SAS Files,
them. 9.4. So in that, actually, I've done here. Yeah, so the File Explorer, perfect.
Okay.
Go to Documents.
Document,
We
where's
don't
that?
have a Documents file.
Oh,
Documents.
documents, okay.
My SAS files. That one. 9.4, go in there. And then you would dump the programs in there, and then you can access them from Forecast Studio.
Make sure
And so how?
you got to refresh.
How do you
it.
just?
Yeah, you have to exit the.
Yeah, so you have to go
project
to a
screen.
file explorer, like outside of Forecast Studio.
Oh, okay.
Yeah,
so it thinks that your data file is in Documents, My SAS Files 9.4.
Yeah, so you don't add the files through Forecast Studio.
I got it.
Yeah,
They have to be there.
Now, how do you refresh?
So
it?
now, how do you refresh it?
Cancel and start again.
Oh, yeah,
Cancel and
close
start
out of
again.
Oh, I got it free.
You don't have to close it, just hit cancel.
Yeah.
You cannot go
File new
previous and
project.
forward.
Okay.
Let it previously.
Yes, cancel and start again.
This new project.
Okay, back to square one.
Back to square one.
Let's see, it's Cameron. Hey, Cameron, you're not white nose after all, man.
Which was good.
Rich is good.
We good?
You got it.
We got it. Distance, guys. Janelle, you good? Okay. So we click on Arima PDQ, and then we don't have any by variables. So this would be if we were doing this by region or by store. So we don't have any of those. We just want a single model. So we click on next. Then we've got to tell it which column is the time variable. So we're going to click on the triangle after time ID variable, the V upside down, and we're going to select date. We good?
Yep.
Then we click on next, and then it shows you whatever variables are left, and the only variable left is YT, and we have to tell it the role. So we're going to call it the dependent variable. So in a couple of weeks when we do transfer functions, it's going to do transfer functions too, because we can tell it x's as independent variables, and it'll do a transfer function. But let's learn how to crawl first.
Crawl first.
We good? Oops. Now, do we have any problems with missing and all that jazz? We don't, so let's click on next. Now.
Dr. Sheeter, I have a question.
Yes, sir.
So back on the step 5 of 8 screen, there's an accumulation column that's set to sum of values. Is that correct?
Uh-huh.
Okay, thank you.
Yeah, so again, if we were going to accumulate forecasts across regions, right? So imagine we had this thing where we forecasted sale in 4 regions and we wanted to know what the total sales were. Our forecast for the total sales, we'd accumulate by the sum. So, guess what? You know me, I don't always accept the default, so we're going to change some of the forecast settings. Imagine that. So we click on that, and then we go down to the selection criterion, and it has mean absolute % error. Mate, we will use that shortly, but I'm a man that believes in valid models, so we're going to choose the Schwartz-Bayesian information criterion. So it's going to pick the model with the smallest value of SPIC.
We can't choose, there's one here that says R squared, we can't get.
Yeah, please don't wind me up, mate. Don't wind me up. There's a lot of wind me ups in there, right? It's like, really? I think they did that just to annoy me. Okay, we good?
Uh-huh.
We're going to forecast 12 periods. That's automatic. It thinks most things are monthly data. Here we don't have, we're not interested in forecasts, we're interested in just what model does it get. We good?
Dr. Sheeter,
Yeah.
with that, does that tie into when we did the date variable, we said day, and so those 12 forecasts will be 12 days?
That'll be 12 days.
And have we said month or years? It would be?
Yeah,
Okay.
that still does 12.
Okay.
You'd think if it was days, it would want to forecast 30 days, right? But whatever you put, it's still just going to forecast 12. You change that.
When you selected the Bayesian criteria, there was also some of those things at the top.
There's all sorts of things you can
Yeah,
have.
what are those?
They're put there to wind me up, mate.
Okay.
R squared, random walk R squared.
No.
Oh.
Before that.
They're the holdouts. We will get to that.
Okay,
So
we
what
keep
I'm
it
trying
as
to do
default.
is just do the most straightforward way, understand the output.
Okay.
It's like when you get a new television system, show me how to play Netflix, turn on the television, how to record a show. We're just doing that. Next week we're going to be really wild, but let's just, right? So it's like when you go to South America, I say to the guide, I'm going to stay with you, mate. I like to walk on the path with someone who knows where they're going. I'm not going to be like some of these mad people who actually charge up the hill running by themselves. That's not me. Okay. Click on finish. And then this little wheel will spin. It's thinking. This is where we need the music. I call the think music, right?
Oh,
I'm there.
got something.
Elevator music.
Elevator music. So when I was a kid, there was this $66,000 question, because $66,000 was a lot. And they would have somebody in a booth with headphones with the music playing while they were asking the other person the question. So this says it picked an ARIMA model. That's good. Exponential smoothing, ESM, right? UCM is unobserved components model.
Where are you seeing all this?
So see model family.
Oh, the other one.
ARIMA, right? It says that it picked the ARIMA model. It didn't pick exponential smoothing. I don't know what this is, and that's the unobserved components. And it tells you where the forecasts fail. So again, imagine you have a lot of missing values and you want to forecast for this for 60 stores. Is it still turning?
Yeah. Well, behind it, but I think
Yeah.
it's, I think
You get the result, it's turning behind it.
Yeah, it's still doing something.
Okay, it hasn't given you that little thing.
Oh, it did.
But we have the charts.
You have the charts,
It still
good.
says it's producing forecast, but we have the charts.
Yeah.
It says REMA.
Yeah, you've got that, right?
Yeah.
And then behind it is this picture,
Yeah.
got it.
right? But once so I just screen captured that little thing
Okay.
by itself. Now, what we have here is called the forecasting view. So it's the data and the forecasts, and they look pretty good, don't they? Yes? So here's where I just really lose control of myself, and I want to click about 5 things through, because I want to know what model it fit. But we'll get to that. So we're going to click on the next tab and call the modeling view.
You have
Don't do that,
to
it's-
close the charts.
You've got to choose the
Then
charts,
stop the
close
screen
the
view.
charts.
Ah.
So you've got to go here and push close.
And then what do you do?
Then you can click on the next tab.
So you've got to push close. You look at
The
those.
modeling view?
Then you go and click on the modeling view.
Got it. Oh, that's still turning, the wheels are still turning.
It makes me
Yeah,
weak.
yeah.
Look at the white noise.
Okay, white
Camera, you're not there, man.
noise. I love white noise.
Look at the white noise. Now we will see that this system is supposed to be intelligent, but it sometimes produces models that don't pass the white noise test.
But this one's good.
This one is just beautiful. But it's an easy contest, isn't it? Right? It should be. Yes? The white noise test is beautiful. So we're good? I actually like it when it falls over. But you know, I'm weird. So then we're going to go and click on tables. You see this thing, tables? And we're going to select parameter estimates.
Ah, good.
Okay.
Give me one. Yeah.
Tables and parameter estimates, and this really small box
Perfect.
for people with young eyes, right? Yes, can you read that?
Yes, sir. You can
Yeah,
do it.
so here's what you do. You right click on that table and say copy as an image. Copy as an image. Yes? Copy as an image, and then you can paste it into something
Okay.
where you can make it bigger.
So you can do the
Is there
spreadsheet.
a way to do it this over? I mean,
Make the image bigger. Show me, I don't know.
no, I'm just saying, like, you know.
Look, I've been
you
using
should
this
do
for
something.
3 years, and I'm just telling you the way I do things. If you could come up with a better way, I'll donate money to your favourite charity, okay?
It's called Alejandro.
So, we'll see that this uses conditional least squares. It doesn't use maximum likelihood, but it picks a model. We don't know whether it used differences yet, but it gets a mean of 0.33, the MA coefficient around minus 0.6, and the AA coefficient around plus 0.6. A little bit different to what we got, but in the same ballpark, right? Yes? Now, we can also go to this tab and click forecast values. So below parameter estimates is forecast values, and it gives you a series of forecasts. And you can copy them and put them into jump and all that sort of jazz. That's sweet, isn't it?
Tables, forecast values.
Tables, forecast values. Are we good?
Okay.
Click on tables, click on the triangle next to it, a menu drops down, you click on forecast values.
Come on, Gigi.
Are we good? Distance, guys? Are we doing good?
Yep.
Good.
I'm hearing it.
Rocking and rolling, we good? And then, look at all of these little symbols up here. Look at these little doodads. There's a lot of things in there that we can monkey with. Right? This is where they say, now here's how you change everything on the TV. And I say, Do that slowly because I want to write it down. So, we're going to go back and double click on generate a REMA model leaf 0. So we go up here. You see how it's got this generated a REMA model? We're going to double click on that. Do you double click on that? Up pops a box, and the box tells you that it fit a REMA 111. D equals 1, D equals 1, Q equals 1.
Yeah.
Are we good?
Good.
It fit an intercept, and the actual algorithm it used is high performance diagnose. It's a new time series algorithm.
Why is it capital? Why is it big P?
Yeah, because again, they're just winding me up to the gator. I don't know. It should be little
Should have
p.
been little p.
Yep.
In the code, it's little p.
How do you know?
No,
Because
no.
you can look at your
You
code.
can view the code if you go down and look, and notice that it used method equals CLS. So we're going to show you how you could update all of those settings. You can change the CLS to ML. You can do all sorts of things. We good?
No, you're right.
Now,
Capital P should be the seasonal thing, right?
if you go back to these things here, you see the rightmost icon? If you hover over that, it says diagnostics, right? If it hover over that, does it say diagnostics?
Can you show us where?
The fifth icon,
Looks like a little.
the last icon on the right.
Oh, yeah.
Yeah, click on that, and up will pop a bunch of stuff called diagnostics.
Yep.
So view diagnostics and diagnostics, and I have deleted everything that I don't like. We'll get to it. Right.
Dickie Fuller?
I deleted the Dickie Fuller test.
Seasonal.
Dickie's a good mate of mine. You know how I hate doing tests. So part of this diagnosis that this thing does is it tests everything. It goes mad. It tests to see if there's seasonality. If so, yada yada. So it's actually easy to fool the thing based on these tests. So tests are not part of my statistical vocab. There's only a limited number of tests you should do in your whole life. Anyway, so if you look, the best model selection is 111, right? And notice it puts little p, little d, little q.
Here it's little.
Yes, here it is, yeah.
The code is different.
And then the SBC is 69. If you do an exponential smoothing model, which has a level, a trend, and a dampening, it's like the whole 9 yards, it gives you an SBC 5 times higher, 307. I think we win, don't we?
Dr. Stevens.
Yes. Yes, sir.
So I know that the auto or REMA function in R, you can shut off those tests. That way when it fits the model, it doesn't look at them. Can you do that with this as well?
That's a good thing. Not that I'm aware of. You can put in your own model. Next week we're going to add some of our own models to do comparisons with. But this is the way I think that this does. The way it chooses 111 is it's based on a bunch of these tests.
Okay.
Okay? So, now, create a copy of the selected model. Click on the fifth icon from the left. Create a copy. The whole reason for creating a copy means you can monkey with it. You can change settings. You can't edit the current one. You can create a copy and then you can change stuff. Are we good? The fifth icon. So let's go back. Which is the fifth icon? 1, 2, 3, 4, 5. This jobby. If you hover over it, it says create copy. Yes?
Yep.
Good. So create a copy. So notice that it's got the intercept check. It did that automatically. If you do 2 levels of difference, it will not fit an intercept. So it's got an intelligent system to figure out whether you need an intercept or not. In the next example, which is real that we'll look at, we're going to worry about outliers. So we didn't turn on the outlier test, but we will. And then next week we're going to worry about events. So in the wicked thing, for instance, right, if Easter was, you can put in an event called Easter, which moves around. And it automatically finds Easter for you. Which is pretty nice, isn't it? Yes. And then if you look at the convergent criterion, there's unconditional least squares, conditional least squares, and maximum likelihood. So we could get back what we got, right? Convergent criterion, method. You click on the triangle next to method, it shows CLS, and that's a smart choice because that converges more often than maximum likelihood. Right? But if we wanted maximum likelihood, we'd click on this triangle and choose ML. Right? That's in the estimation tab.
Oh, that's another tab.
Yeah, see estimation down the bottom? Sorry if I didn't say that correctly.
That's not part of the...
Part of the subset arena model, if you copied it.
That's because we copied this. So that will allow us to monkey with things.
So
Right?
do you save it as a different name?
You can save it as a different name. Here it's called leaf copy.
Okay. So
Okay.
you just press OK there?
Yeah, well you can if you wanted to rerun. I'm not doing a rerun.
Okay, well,
I'm
where,
just
where did you find that thing?
Estimation?
Estimation. I clicked on estimation. See how that's highlighted? And then it brought all this up.
Okay, got it. And that's showing us CLS, so you can change
CLS, you can change it if you want. If you're old-fashioned like me, you might want maximum likelihood.
Okay.
Okay? So, that's the way around. That's the standard way that we've done, and we get back essentially the truth, right? Now, one of the things that this program allows you to do is use holdout samples. So, we could do MAPE, percentage error thing, on a holdout sample. So if a holdout sample is specified, the model is selected based on the goodness of fit statistic in the holdout region. Okay? Now, if a holdout sample was used, the model parameters are estimating using all the data, including the holdout sample. Right? So as we leave 25% aside and say, give me the best model that minimises MAPE. Right? It finds what that model is, and then it applies, it fits it to all the data. And you can argue philosophically whether it should have done that, yada yada, but I'm just telling you what it does. That's cool. So, here are the models based on SBC. And then I think I've got a comparison slide. Now what I'm going to do is we're going to actually go and say, let's do a 25% holdout MAPE. So we're going to refit this whole 9 yards. So I want you to go back to the start and start a new project.
How do we save this? No? Do you have to save this or no?
You should. I mean,
Or do you want us to go back and start a new project?
I want you to start a new project. You can save this, right? You just push exit and it'll save it, right?
So it's pretty much like a SAS creating start saving stuff.
Now the next one, I want you to try and do most of this yourself. So I put a very mini version of the screens, right? So we're going to do a new project, and I called it ARIMA PDQ holdout, because I'm going to use the fit based on the holdout sample. Okay? The second step is going to be the same. Select the data, SAS user, ARIMA PDQ. We've got to tell it the time ID variable is date. You've got to tell it that YT is the dependent variable, and we're going to accumulate or aggregate over a sum. And then we're going to change forecast settings. And this is where I got asked. We're going to check off the first box. Use a holdout sample for model selection. So 250 or 25% of the points are going to be used for model selection. And I'm going to leave the selection criterion as MAPE, mean absolute percent error. Mean absolute percent error.
So you tick that box and then?
You just tick that box, that's it.
And then change the numbers.
You change the numbers. What were the numbers on?
250.
250, 25% of 1,000 is 250.
No, for mine it's by default it has 2.
You have to change it to 250?
You have to change it. You have to type those numbers in.
It looks at the first number first, and then it has over the percentage, it'll just take that percent. Because you have 250 and 25%. So,
And because 25% of 1,000 is 250.
yeah, so if I put 325%, will it take 300?
I don't know because I'm anal and I want to put those two numbers to match.
Oh, yeah. So you just might not know the size of the data sometimes, and so that's...
Well, the good news is this is an empirical science. You can try both ways and see what it does. Right?
Okay.
We good?
Yeah. And then change the
Excuse me,
Yes, question.
which 25% of the points does it select?
That's a really good question.
Must be right.
I think it does it randomly, I think. I don't know. We have to look. Well, let me just say, when we get to the chase, you'll see this once and probably, hopefully, never do it again. Okay? So that's why I've not invested much energy in figuring out what it does.
And SPC?
So, it predicts, it finds an exponential smoothing model as best. Yes? And have a look at the white noise test. Shoot me now, multiple times, very quickly.
Going to jail.
It's a lot of noise.
Yeah.
But it found ESM as the best.
Exponential smoothing model as the best.
Yeah. And,
So we have an ARIMA 111.
and where did you find the white noise? I forgot.
Again, if you click on modeling view,
Gotta close that.
Oh yeah.
you've got to close the little box.
Yeah,
And you click on the modeling view.
yeah. Oh, ugly. That's bad.
Right?
Yeah.
So if we were really interested in forecast accuracy, what criteria might we use? AIC. And AIC is one of them. I'm sorry, I won't fit invalid models. There's just never enough. While I have a breath in my body, I won't do
They
this.
can torture you, Dr. Sheehan.
They could, mate. They could do everything, right? But I'm not going to do this. So, let's have a look at what happens. The MAPE for the exponential smoothing, which is just a simple exponential smoothing model, is 10.5%. The MAPE for the ARIMA 111 is nearly 50% bigger, 14.6. Yes? That was in the diagnostics, right? Everybody see that? I deleted all those tests because I don't want to look at them either.
Once you close that box that has a diagram, is there a way to get that back?
No, not that I know, sons. So that's why I always paste it in the output. Then if you have a look at the forecast, Have a look at my friend exponential smoothing model. Oops, I can't draw. What do we notice with the exponential smoothing model, which we saw in class?
It's the same.
It's the same. It's the jolly same. So this is saying if you want to do one step ahead forecasts, right? One step ahead, that the exponential smoothing model will have a smaller mate than the ARIMA model. So you can beat the truth with this exponential smoothing, but it only works really one step ahead, right? Now, if you think about it, you saw the series. Did you see any place where 12 points in a row were flat? No. And again, I changed the ARIMA PDQ this year, and it gave me this really simple exponential model. Last year, it gave me one where at least changed the mean a little bit. Okay? So, the bottom line for me is if you want to minimise forecast error, please use AIC as a criterion and look for valid models. You'll typically have a valid model. You'll have too many parameters, right? Remember AIC, when we do that model comparison thing, always puts in higher P and higher Q, yes? So do that, but at least it'll be valid. Are we good? All right. Let's try a real example where we don't know the truth. Okay? Yes, so.
If you go back to the software, just for a sec, and to the software. No, I mean to the actual SAS Forecast Studio software.
It's been in PowerPoint.
I'm in PowerPoint.
He hasn't been in it yet.
Oh, you haven't really been in?
I'm not in.
So there's a way to recall diagnostics. There's a menu icon called series, and that has view diagnostics, and that brings up that whole.
That little box.
Yeah.
But if you just click it, the icon again, it comes back.
Right.
Icon for view diagnostics.
So here's the deal, guys. I'm very happy with my life. And I know my way around this, so if you want to do something fancy, good luck to you, right? Yes, are we good?
We're good.
Good. All right, so we're going to do main turnpike transactions. I updated the data and got some more months. Right, so we've got more months to predict. So since we started the semester, they put up May, June and July. So I updated the data. But we're going to use this till the end of 2016 to actually predict 2017. Is that good? Good. Now, when you look at this, what do you see? Seasonality, but I also see there's a little bit of a change here, right? The means there's a change in the mean, or a shift or something, right? Looks like a shift, doesn't it?
Yeah.
Yes? So, guess what we do? I'm going to take the seasonal differences first because they're so strong. Right? They're very strong. Yes? Look at the Christmas trees. Here. Strong. Stronger. Yes? Now, does this look stationary? The mean changes a bit, doesn't it? So you'd be tempted to do another difference. Yes? So do a first difference and a non-seasonal and a seasonal difference. And so when I did this, I actually thought, it'll be fun. Let's actually allow... Oh, I did it the wrong way around. Oh, that's dumb, isn't it? What I should have done... Ouch. I was trying to be cute. What I should have done was ask for the first differences either to be 0 and 1. I put the seasonal differences as 0 and 1. Right? It's very obvious that we should do seasonal differencing. It's not so obvious that we should do first differencing. I apologise for that. Wow.
Minus 2 points.
Anyway, if you have a look at the both, when it's both differenced, what do we see? We see 2 lags here, we see 1 lag here, right? And then what do we see here? 12 and then really nothing. It's kind of hard to tell, isn't it?
Yeah.
So what pops it out of our porridge? A REMA 211011. And a REMA 210110. They're the top. Okay? So did I do that wrong too? That's the thing of updating the notes every year. 211011 is correct, right?
210.
And then the second one is, excuse me, 011011. My bad.
The first one is 210011.
Okay, yes, 210011. Yes.
Second one is 011011.
So at least I fitted the right model on the next page. 210011 is the one with the smallest
Okay.
SBC.
So the graph is actually correct, then it's just the notes that
It's
are...
just, yeah, the manual fool that typed this stuff
That's all right.
on Saturday.
Looks good.
Now, if we look at the forecasts, they look pretty good, don't they?
Yeah, me too.
The forecasts look pretty good. We passed the white noise test beautifully, don't we?
Beautiful, beautiful.
Yes. We still have a few points that pop out of our porridge, but the things are not significant, so we're okay. Then the next thing we would do is we would check for... then the intercept term is not significant, and we've got 2 levels of differencing, so let's do it without the intercept. Let's remove the intercept, because we know that the SAS Forecast Studio is going to fit a model with no intercept. We've done double differencing, we expect no intercept. Right, we've done the first differences and the seasonal differences. So, we find a shift at 99, which is presumably that one we saw in a couple of additive outliers. We use our age-old process of going back and refitting those. The first thing we look at with much excitement is the white noise plot, and it passes, right? Very good. So we've got our 2 AR parameters, our 1 moving average parameter, a level shift, and these outliers. And in terms of absolute numbers, there are around 300,000 or more. Right, 300,000. We don't find any extra outliers, so we stop. We say thank you to the statistical higher being for giving us a straightforward example. Yes? Yes? There's the code. It's on the website. So let's actually do this in SAS Forecast Studio. See what they get. Sorry? What do you mean? They're going to get the same?
I mean, I got the same model.
Okay, good. You're ahead of us, Richard. Well done.
I thought you were supposed to do it.
No, well, you can.
I thought you were today.
So we're going to open it up. Main turnpike transactions is going to be our name.
Doing this together, it's a team. Sorry.
Making us all
Long.
Are we good, guys? We're keeping up?
The time variable is here, right? Time is time.
The time variable is time. I made the files nice. I just put the 1 Y column so we couldn't be confused. Right? Oh, well, you've got both. You've got net fair revenue and transactions.
Transactions is
Transaction is the dependent.
Transactions is dependent. If you do both, it'll fit two separate time series models if you tell them both one. But you can imagine they're not going to be related simply because they're going to put up the fare over time. So, we're going to change forecast settings. And here we're going to look in this outlier detection box.
Did you do the,
Is that on diagnostics?
Yes, on diagnostics. What did I do, Tathagata?
did you do the 30, the data partition?
No.
Okay.
So no holdout.
No holdout. I'm going to use SBC, Schwarz's Bayesian criterion. Change other forecast settings. That's going to be on the next slide. Right now I'm doing diagnostics because that's... So, change forecast settings. You get this box. The third one down is called diagnostics. That's before model selection. So I do that first.
So what did you do there?
I clicked on diagnostics. I entered in 6. So you want to put the smallest number you can live with. I'll explain why shortly.
Okay.
And you want the percentage to match the number, at least roughly. Now what this does is 05 is the overall test. So when we do our way with SAS, it checks each outlier against 0.005. Now if you do 20 of them, what is the overall level? It's going to be pretty high. Right? So this says, I'm not going to do it that way. I'm going to, you tell me how many I'm looking for, and I'm going to do the test based on the number I'm looking for and that overall level. Okay? Now, if we did this in a really rough way, which is not what they do, but they won't tell me exactly what they do. Imagine we were looking for 5 and we had the overall level 0.05. Then we could do each one at 0.01. Okay? So, and we'll see more about this next week. I changed the 0.01 to 0.05. I think there's, at most 6 outliers. I then go and push model selection. Click on that and change to SBC.
And did you do anything on the forecast tab?
No, not yet. Again, we're just adding a little complexity, right? We want it to check for outliers and level shifts and find the best model at the same time. Isn't that a beautiful promise? Yes? Then we're going to click on finish. We're not monkeying with anything else. So the only thing that's different to the first ARIMA PDQ is we put the outlier thing on. Okay, good. It picks an ARIMA model. That's good. The forecasts look really good, don't they? Yes? The white noise looks beautiful.
Just gorgeous.
So you know why I look at that first. If that's rubbish, as we say in Australia, I'm not even tempted to look at the other rubbish, except for a laugh. Yes? Good. So it found outliers. It found 2 additive outliers and no level shift. That's weird, isn't it? Right? In the diagnostics, remember I get rid of all those test boxes. It found 2 additive outliers and no level shift.
Where did you see that?
So remember, you click on the last icon, diagnostics,
Yeah.
and if you have to scroll down because it's right at the bottom. So what I do is I get rid of the Dickey-Fuller test, the co-integration test, all those. I just keep clicking on the X's.
Okay.
And then what will pop out of your porridge is this thing called a REMA outlier selection.
I don't have it.
Yeah, you do.
It's there.
Agreement outliers.
Oh, yeah. It's one of those boxes, actually it goes right.
Yeah, it goes right over there. That's why I like getting rid of the ones that I don't look at.
Okay.
So what do we think? Do we think 2 additive outliers is a good deal?
No, there was definitely a level shift.
Was there?
I don't know.
At least we did.
Looked like it, didn't it?
Looked like it.
Looked like
But
it.
we also
Or was
picked it
it?
up.
Or
in the
was
other
it?
Now,
one.
when the other one picked it up,
Yeah,
Or did it?
the other one picked it up. Where did the other one pick it up? Where was it ranked?
99. 99.
It found it as the most important.
Yeah. That's a big, big shift.
So, here's the first of a lot of experience. The outlier stuff in the regular SAS and the outlier stuff in this SAS Forecast Studio is different.
But you know
You
what?
generally find more outliers using the SAS ARIMA approach that we've used the whole semester. Here, this is more modest and finds less outliers.
But strangely, the observation number 98 is where it finds an outlier, whereas 99 is a shift.
Yeah, it's around the same place, but it doesn't think it's a shift. Right?
Does it ever find shifts? Like,
It does.
So,
I see some shifts in your future. There's an exercise you're going to do next on your own. I see some shifts. Okay? It does find shifts. So it's not like it's not looking for it. Okay?
That was flexible. That was good. I like that.
Okay, then we can look at what I did was go table parameter estimates and blow it up. So it found 2 shifts. February 15 is a negative. February 12, 2 additive outliers. February 15 is a negative, and February 12 is a positive. Mhm. So let's look at the actual forecast region. Right, let's look at the actual forecast region. Where is 2015? That's here, month 1, 2015. So my arrow has moved. My arrow should go here, right? This arrow needs to move down to here. That's month 1, right? That's month 2. And if you look at month 2, that is below where you'd expect it, right? Yes? And then if you look at 2012, I got the arrow in the right place, right? 2012, it was assuming that if you look at month 2 is generally the lowest month, right, in all of these, yes? And this month 2 was higher, so it says this is higher. But the interesting thing is it didn't find any level shifts over here, right? Didn't find any level shifts. We good? We understand what it did?
still seems to do the forecast right, even without.
The forecasts look really good. We're actually going to compare the 2 sets of forecasts. Okay? So I've got the 2 models together. So the coefficients, one of them, the one with SAS Forecast Studio is conditional least squares. We've got maximum likelihood. The MA coefficient, 0.45 versus 0.31. The AR coefficient, minus 0.78, minus 0.85. AR2, minus 0.26, minus 0.3. They're pretty similar, except this first one. Differ by about 1.5 standard errors. Still not dramatically different. And this additive outlier at 62 is the same, so they're very similar. They're very similar. Whereas this finds a level shift at 99, which is positive. This finds an additive outlier at 98, which is negative. Different. Different. So you can click on the generated model to see what it fit. It did double differencing like we did. P equals 2, Q equals 12. It has no intercept and it has those two additive outliers. And it used CLS.
Is it by default they use CLS?
Yes, by default. Because as we know, I carefully find these examples which illustrate ML doesn't always converge. CLS much more often converges. And if you want to have a system that works right with the novice user, you don't want things that don't converge.
So in our code, we use ML, right?
Yeah, yes, we typically start with ML because if the model is correct, maximum likelihood is the optimal fitting mechanism.
But if you had used CLS, would it have picked up the...
That's a really interesting thing. You might want to try that. I haven't tried that.
Hey, Dr. Steve.
Yeah.
On the view code, when we grab this, say we want to grab this SAS code, does that run in SAS Enterprise Mind?
I haven't tried. JT, that's a great question,
okay.
sir.
Well, I'll let you know.
Yeah, let me know. We've got to make sure we have this module called HPF Guide Dose. And then we create a copy to look at things, and you can see what it did. It did both differencing, it didn't fit an intercept. So the point here is it will decide whether it needs an intercept or not, right? If it does double differencing, it gets rid of the intercept. But last year I did an ARIMA PDQ with the mean 0. And it was smart enough to know that it didn't need an intercept. Okay? But again, it does all this based on tests, not on... What's our mantra? Our mantra is to base things on penalised, so SBCs, right? If you want to put more parameters, you've got to improve SBC, which includes a penalty for that extra parameter. It's a different mindset than doing hypothesis tests. If you click on additive outliers, right, in the leaf copy, it tells you what they were. Right? That they were both additive outliers, February 12 and February 15. Right, all I did was click on them. All I did was click on, I made a copy, and then I clicked on outlier variables. Good? Then I'm going to go back to the modelling view, and I'm going to select the forecast values. Because I want to compare my forecasts from SAS, from the model that we built ourselves, using maximum likelihood, right? The two outliers and the one level shift, with the forecast produced using conditional least squares with two additive outliers. We good?
Good.
Now we get this table. Now, here's where I want you gurus to try. You can right click on that table and say save as, right?
Right click, see?
Save as? No. Copy as.
Copy as,
Copy image.
copy image, or copy as a file.
Spreadsheet. Yeah.
Copy as a spreadsheet. See how you go with that. See what happens when you do that.
I tried that before, nothing happened that I wanted to have happen.
Nothing happened.
Nothing good happens, is what I'll say.
Yes, that is correct.
I don't know what happened.
Mr. Sass, you have a great product, but in my humble, meager abilities, I can't get it to copy as a spreadsheet.
Pick up one cell.
It gives you one cell called OBS.
Oh,
Yes?
it does, yeah.
Anyway, I'm glad that the gurus get the same thing. So what do you do now? You use colourful Australian language.
And manually do it.
No.
What?
No, we're not manually doing it. You can actually go and, in this previous box, when you do forecast values here, you can actually highlight all of them, paste it into Notepad. Do that for me. Highlight all of the values, not the headings, just the values, paste it into Notepad. You know what I mean by Notepad?
Copy image.
No, not image. You want to go back to where it appears here. So if you go forecast values,
Yeah.
the forecast values appear on this screen. Then I want you to go and highlight from row 2 down and go control copy.
Control copy.
Yep. And then open up Notepad and go control V.
It works.
What happens?
Column-based file.
You get a column-based file, right? Without the headings.
Without the headers, that's correct.
Without the headings.
I don't get it.
Distance, guys. Did you see that? Are we good with forecast values? Go to the first row with the numbers, row 2. Highlight all the numbers. Control C. Open up Notepad. Control V. And you'll get data in columns, which you can paste into Excel.
And the header show is HTML.
Yeah, HTML. Or
Okay, again, you're much more advanced than me. I just type the headers in myself. But if you can recover them, good luck to you.
I think that's why it doesn't paste in Excel, it's interpreting those.
Okay. So then what I did was I pasted together into Jump. You know, it's easy in SAS. It says save as, send to Jump. I took the actuals to transactions in red, the SAS Forecast Studio forecast in green, and our blue forecast. They're similar, aren't they? But they're a little bit different. Yes? They're similar, but they're a little bit different. So, let's look and see who wins. Who wins here? It's a tie there. Blue wins here. Right? It's very close here, it's very close there. Blue wins again. Blue wins again here. It's very close. But they are a little bit different, aren't they? Yes? They're a little bit different. The other way we can do it is percentage error. Percentage error. So, blue wins here. It's very close here. Blue wins here. Red wins here. Red wins here. And red wins there. So red wins. It beat me, and I'm still unhappy about it. So it's a little bit different, isn't it? It's a little bit different. Question?
We say it's artificial intelligence, but how are we getting the parameter estimates? I thought it was non-parametric.
No, it's artificial intelligence in the sense that it chooses, you have to say, you want, we just kept the default. So it's going to fit an exponential smoothing model and an ARIMA model, and always compare those. Always. But exactly what exponential smoothing and what ARIMA, right? Is it ARIMA little p, little d, little q? Have we got a big P, a big D, and a big Q? That's all done without any of our monkeying around. We don't say anything, right? I'm surprised that the outliers are not turned on as a default. I remember going to the student presentation, not my students, and I had to bite my tongue where there were outliers that would, you could have me blindfolded and with 10 days of no sleep and I could still see the outliers. And then going, SAS Forecast Studio can't find the outliers because you have to explicitly click the outlier attached. Yeah.
So if you would take the same model as the Forecast Studio presented and type it into regular SAS with the same outliers, I guess it would...
It should give you the same thing. So a good question would be, what happens if we went back and refitted our model right from the start using CLS and not ML? See what outliers it finds, right, and whether they match. But I've seen examples where we've found 15 outliers and level shifts, and this thing finds 3 or 4. It's just got a different methodology. It's more conservative. Alejandro.
Why does he compare always versus exponential smoothing?
Because that's what most people do in the real world, sir. ARIMAs and exponential smoothing are the 2 most popular sets of models. Okay?
But exponential smoothing is equivalent to MA1, right?
Well, it's an MA1 model. You can put all of these other fancy things on it, right? You can even put seasonality in it, but it's a subset of a ARIMA model. But again, if your mission in life is to have a low make with a 1 step ahead forecast, then exponential smoothing will often win that battle. But the models are not valid, and I'm sorry, in my statistical religion, I'd rather give up a few make points and have a valid model. Right? This is just trying to mirror what's done in the world. I'm still a young man, mate. I hope that exponential smoothing goes away before I'm dribbling it in the wheelchair, okay? I'll be happy. Javier will wheel me out, right? You're laughing, I'll still be here. You get out after 5 semesters. So let's think about what's the artificial, what does it do? It decides on the basis of a bunch of tests. Is there seasonality? Is there trend? Right? Do we need first differencing? Do we need seasonal differencing? It uses an information criterion that you tell it, SBC, once it's decided on that, to pick the model. But at the same time, it allows for outliers and level shifts. Very neat, isn't it?
So all the stuff that we would do up front with jump, where we would do, look for the model, look at the difference, ARIMA group,
Residuals.
it's doing all of that stuff.
It's doing all that based on tests.
Wow.
We don't do that. We do all of ours. What did we do in this example? And what am I going to do for the next 100 years? I can't remember my own name.
Don't we look at the residuals in the box-Lume plot and we decide, we make that decision, right? Manually.
We do the manual thing.
Yeah.
And I'll show you next week. We're going to beat the bejeebies out of this with some real data sets because it gets confused. You put a season time series analyst against this little machine, we can beat it. Okay? So I always start this way with the manual one. Now, sometimes, like the wicked one, was wicked and it wasn't clear what to do, right? It wouldn't be nice to say, okay, SAS Forecast Studio, blow your hair back, tell me what you would fit, right? Yes?
Yep.
That would be a help. But I always start with this step. Yes? Yes, Alejandro.
Assume that you find a valid model and everything.
Yeah.
You jump. And
Yes.
so on. Would you still just do this one just to check? Or see if there's something better that you haven't considered?
Not me, mate. I've got the courage of my convictions. I've done the whole semester, I haven't checked anything. You can. I haven't. If we've got valid models, what do I want to monkey with this machine for? You can. But I'm sorry, I'm old, I like my old ways. I've only had this for 3 years, I didn't grow up with it. But notice how I did this, I held this back. Imagine I'd given this to you the first week. You'd have been pushing buttons and all that sort of stuff. What we want is principled arguments about valid models, don't we? Right? When things don't quite work out, what do? We go back and look at ACFs and PACFs and decide whether we need to difference, right? Yes, that's the safest thing in town. Rather than some algorithm which is not completely clear to us because that's their intellectual property, right? Yes? But I'm old-fashioned, mate. Old school. Among some of the SAS people, I'm young. But anyway, it just depends on your age, on your cohort set.
Man, Richard's already done the homework assignment.
So, let's actually have a look at the homework thing, which we're going to do in groups. So, where is Jean? Here we go. Good. Okay, we want so this is the Taxi and Limousine Commissioner in New York got so hassled by all of these freedom of information requests, including one a Professor Sheether put in, that they now publish this stuff on their website. This is the monthly fare box. Analyze, specialised modelling, time series, fare box per day, and date. Oops, not a good business, is it? Now, most of the time series we've looked at are going up, right? We know from business that earnings should increase, not decrease. And if they are decreasing, we're headed to a bad place. Yes? Now, what else do you see? It could be some seasonality. What else do you see just from looking at the time series plot?
So the maintenance decrease.
Well, I see a level shift. Boom, boom. So we're here, we go up and then we go down. It's like we're flat, we go up and then we start going down. There was a fare increase in New York City in 2012. It was the first one for like 8 years. The short version of a very long story is one of the reasons I ended up at Texas A&M was my wife got recruited to come to the US, my then wife. She was supposed to work in Houston in executive search. She didn't work one day in Houston, she worked in New York City. So I used to commute from College Station to New York City 3 times a month. I had great stories. I had this Indian cab driver where there's all the bridges and tunnels were all accidents. And he says, "Don't worry, sir, I know the way." I say, "How long have you been driving cabs, mate?" 2 weeks. It was interesting. Anyway, so I lived through the New York City. Suffice to say, it's impossible to stay married when somebody lives 8.5 hours away. Anyway, so there's a level shift.
It's not easy to stand married when you're in bed.
Anyway, Cameron.
In this case, since obviously we're concerned about predicting the future,
Yeah.
to deal with the level, rather than having to deal with the level shift, couldn't we just multiply it by the fare increase just to?
Yeah,
Those numbers wouldn't be accurate anymore, but they'd be.
You could.
fine.
You could do all sorts of things. You might even snip it off and say, let's actually start predicting from when the fare was the same. So I'm just saying, look, you've got to be careful about just getting something and sticking it in a system, right?
Yep.
It's best to use subject matter expertise. But let's, for argument's sakes, see if we can build a model, and let's see what you and your groups will see what Forecast Studio does. Are we good?
Dr. Scherer.
Yes, Diego.
Question, is this series stationary? Because
No.
it looks like it's not.
It's not. We're going to have to do things to it, right? We're going to have to do some differencing, absolutely. But we're just looking at it right now and using me as the subject matter expert, right?
It's just a quick
Thank you.
read.
Okay. So,
Shit, one question.
yes.
Using the artificial intelligence tool that you just gave
Yeah.
for your studio, for the outlier detection, I noticed that you tweak the number of outliers and also the coefficient of 0.05 that you use.
Yeah, I want that to be the overall value. Sometimes I've been even very wild and said 0.1. Because that's the overall value for the test of all the outliers. Whereas SAS, the 0.005, that's every line. This is adding up all those p-values in some unspecified way, such that the overall level of all of those tests is what that is.
Okay, so is there any guideline for you, what's the recommendation for you to use there?
So the guideline is to use 0.05 and to put as few outliers as you need. So that's what, how many level shifts and outliers do you see? Well, we're going to difference and look at all of that.
Right.
There's clearly at least one level shift, right?
Okay.
Where the fares went up.
Okay.
Okay, but the first thing we're going to do, we can't control ourselves, we'll want to difference.
I'm tired of looking at this.
Difference.
Give me some.
Yes? Okay, let's look at the seasonality lags. Do we need to seasonally difference as well? What do you think?
It looks like every 12.
6 months?
Well, remember the 6-month business is, well, it's usually negative, yeah. I don't know. But we know the thing is 12 months. What about some of these lags? So let's try a seasonal difference as well.
Did you find the jump file? Did you find the jump file?
This is the last data set.
And then when you do both differences, have a look at this. The Boxley-Young thing is not significant till about lag 12. Yes?
So is it saying that the only thing that matters is the season?
What month you're in?
A year 12.
Yeah, 12 months ago.
So, you tell us.
So again, there's some pretty big spikes here. We could have some outliers going on. Yes? But it's not clear exactly how we should proceed, is it? So this is where I hope SAS Forecast Studio could help us, right? Because we know we've got at least one level shift. It looks like outliers are popping out of our porridge. It's not clear what model we would fit based on the ACFs and the PACFs. Yes? So what I want you to do is go into your groups, right? And figure it out. And see if you can come back and fit a model by hand, right? If that helps you fit a model by hand.
Dr. Scherer,
Yes.
Forecast Studio also recognizes the level shift or just the outlier?
Both, it does level shifts and outliers.
But the checkbox that we gotta press is for the outlier?
It does both.
Okay.
I see a level shift in your future. I see a level shift in your future.
Okay, thank you.
You know, I always cook the recipe before I come.
So we know what's in the porridge there.
We know what's going to pop out of your porridge.
It's going to pop.
So what I'd like is two things. I want you to use SAS Forecast Studio, where you can go bing, 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 and get that in 2 minutes. Well, that's not that helpful, is it?
Get that model.
Then go and see, with that guidance, does that help unravel this? Yes?
Yes.
See if you can come up with a model by hand, which is the same or different. Are we good?
Good.
Do that in your groups, and I'll see you back here. Let's have a little break, and I'll see you back here at 8:30.
How are we doing?
Okay, welcome back. Let's look at the fare box data. So, I actually log transformed the fare box data myself.
We did too.
Yeah, and then if you look at the two, when you do the differences, I like the one on the right a little bit more than the one on the left. I think the variance is a bit more constant. And if you imagine revenue, we often do the log of revenue because we're interested in percentage change. You're talking to a taxi driver. How much has the fare box gone down per day? If I say it's 20%, that's easier to understand than
$20 or $30.
$42.26, right? So, all right. So how do you do this in? So there's this thing called project forecast settings. Remember diagnostics? There's this thing here called functional transformation. You just click log. And the great thing is it does everything in the log scale, but it produces the forecast back in the original dollar scale. It's just a beautiful thing, isn't it? And with some of the groups I did auto, and auto didn't transform anything. So the other thing that's interesting, because this is a humbling profession. Look at the white noise test, looks very good, right? It looks better than without the log transformation. The other thing that's really interesting about this example, why I got very excited when I saw it on the weekend to give to you, is if you look at the model, it's picked 011,011. Remember I said if you're stuck on a deserted island and you've got revenue, the standard thing is 011,011. Now, it finds a couple of outliers as well, right? Notice too, let's look at the parameter estimates. When we look at the parameter estimates, it actually has an intercept, a constant which is very highly statistically significant. So usually when we do the first differencing and the seasonal differencing, that constant goes away, but it didn't here. And this machine, it loves to get rid of the intercept. So it thinks the thing's better with it. It found a level shift in August 2012. That's an 8.7%. That's again why I like that. Remember, if logs, you can interpret that coefficient as approximately percentage change, that the fares went up 8.7%. What they did was increase the fare, what they call in Australia the flag fall. You sit down in the taxi and it shows the initial cost. I don't know what that's called here. And then the cents per mile went up, and the waiting time also, the charge of that went up. Yes? Then let's look at our forecast values, and it did a whole 12 months. So this is 4,195,000. What's the correct answer? Can somebody look that up? What's the correct answer?
4,037,177.
Yeah, so we're a bit down there, right?
Yeah.
The second one is just over 4 million.
Yeah.
What is the actual value?
3985.
So we're very close there. And then the third month it's 4356.
And we're 4422.
Again, we're not bad, right?
Not too bad.
We're not bad. SARS want to fire us, give us the red card or the pink slip, right?
Come on, sir.
But we're not too bad. You could work out the percentage error.
We
But
get past it.
notice that it's still going down, right? Down to 3.6 million is predicted for January next year. Not a good business, right? Not a good business. Wouldn't it be great if we could get the Uber, right? If we could get the Uber and do a multivariate model. Because presumably as taxis are going down, Uber and Lyft are going up. And there you would think that knowing both would really help you, wouldn't it? Yes? Do we get it? Are we good? Now, let me show you something else that we're going to do next week. I want to make a copy. So, edit selected model, create a copy. One of the things we haven't done, and yet this will enable us to do, is a thing called events. So we're going to do this next week, a new event. So we could call this Thanksgiving. And it uses if it's significant. So I'm going to show you the details next week. So if you have retail, Thanksgiving changes, right? The day changes, Easter changes, it'll fit an input variable for each of those holidays.
Wow.
That's an amazing thing, isn't it? Yes? Good.
So basically in the background it creates a dummy variable and
It creates a dummy variable and it knows where to move it. You just have to click, and there's a whole series of holidays you can push. Mary?
Is this a good way to find out if this holiday is significant? So if it doesn't fit it because it's not significant, and we can say that
You can say, you can force it, but here the thing is use if significant.
Yeah.
You can force use, because imagine you wanted to estimate the Easter effect even though it's not significant, right?
Okay. Sure.
The boss says, look, I really think Easter's a big thing. You force it in and it changes by what? But the standard thing is to use if significant. The whole point is to try and make things easier for you. So let's go back and try and summarize. This works really well if you put in something in a smart way, doesn't it? So you have to do the pre-processing. The log helps you here, doesn't it? The subject matter expertise about the events really helps. Right? If there's something really dramatic, then the outliers might find it. But imagine it's a small but consistent difference, and you estimate, and you've got 5 years of data. You've got 5 chances to estimate 5 small things, which separately mightn't be significant, but put together is. So I'm really excited about using this, but notice I'm very cautious about only putting in something, right? I have to tell it that we need the transformation. I have to know what I'm looking for. Does this model make sense, right? If you just push go, anything can pop out of your porridge. Right? Are we good?
Good.
So I got round to most groups to talk about projects. That's great. We're kicking the can down the road every week at this point, because that's what I want. You know, we learned something new. It'd be really interesting for some of the groups to put their project in Forecast Studio and see what you get. Yes? What pops out of your porridge? Okay, any last thoughts or questions before we call it a night? Okay, next week we're going to really kick the tyres and do some more challenging examples. And then we start transfer functions. Okay. Thank you.